Film Report number 12 covers progress during the period September, October, and November 1965. Development, manufacturing, and testing of S-1C stages by the Boeing Company and the Marshall Center continued throughout the quarter. In October, responsibility for S-1C static testing at Marshall was transferred to Boeing with MSFC in a supervisory capacity. The first firing utilizing automatic checkout equipment in the blockhouse was held on October 8th. The test stage, designated S-1CT, was fired for 40 seconds with all elements functioning as programmed. A 96-second firing was held on November 3rd, and on November 24th, a successful full-duration firing of 150 seconds in the automatic mode was conducted. Marshall assembly of the first Saturn V booster flight stage, S-1C1, was completed on September 27th, and the stage was moved from the Manufacturing Engineering Lab to the Quality and Reliability Assurance Lab for post-manufacturing checkout. Checkout here, a combination of manual and automatic modes, included basic power tests, electromagnetic interference tests, testing of basic instrumentation automatic calibration, and gaseous pressure system testing of each of the 5 F-1 engines plus the overall stage. The S-1C1 is expected to be ready for delivery to the static test stand in January 1966. The forward stage assembly, comprising LOX tank, intertank, and forward skirt for the second flight stage, S-1C2, was completed at the Vertical Assembly Building and was transferred on November 8th to Marshall's newly finished 100-foot-tall horizontal assembly building for mating to the aft stage assembly, comprising fuel tank and thrust structure. The new facility has a large high bay area, allowing crane support above the stage, which was not possible in the building where S-1C1 was assembled. Horizontal mating of the forward stage assembly to the previously completed aft stage assembly was accomplished on November 9th, and component installation is continuing. In Marshall's load test tower, structural load testing of the S-1CS aft test stage, intertank, fuel tank thrust structure was successfully conducted during the quarter. At Marshall's Michoud assembly operations in New Orleans, the S-1CD dynamic test stage, which had been moved into the stage test building from the horizontal installation position in the plant area on August 25th, received only minor damage when the building itself was severely hit by Hurricane Betsy on September 9th. Cell number 1, where S-1CD was installed, fortunately received less damage than the other 3 cells and was quickly repaired. The hurricane damage has not seriously affected S-1C production schedules at Michoud. Following checkout and weighing of the dynamic test stage, which is the first Michoud assembled S-1C, it was moved from the stage test building to the Michoud barge docks on October 5th for shipment to the Marshall Center. The stage arrived at MSFC on October 14th. In January 1966, S-1CD will be installed in the Saturn V dynamic test stand, where preparations are now underway for acceptance. A hydrodynamic support system consisting of 4 large concrete pillars topped by hydraulic actuators with hydrostatic bearings will enable the vehicle to float virtually frictionless on a film of oil during vibration testing simulating flight conditions. Steel bumpers are being erected inside the test stand to prevent the vehicle from sliding off the support pedestals. A roof has also been installed atop the stand to prevent a chimney effect whereby gusts of wind might distort test measurements. The facility's checkout stage, S-1CF, which was transferred from Michoud's Vertical Assembly Building into the plant area in late August, underwent installation of tubing, valves, and electronic systems until mid-November, when it was moved to the stage test building for checkout. The F stage is slated for shipment to Kennedy Space Center in late January 1966. The first 4 flight-rated engines for S-1C3, the third flight stage, arrived at Michoud from Rocketdyne during the quarter and are undergoing checkout. The 5th engine is due in December. Vertical assembly of S-1C3 began on October 22nd with the installation of the thrust structure in the VAB. Major component assembly continued on S1C4. The upper fuel bulkhead was reworked due to hurricane damage. Production of bulkheads for S1C5 began at Michoud in October with the milling of fittings in gore apexes and bases. S2 structural testing was completed this quarter at the Seal Beach facility of North American Aviation Space and Information Systems Division. Although the structural test stage collapsed in the final test on September 29th, the failure occurred at an acceptable load level. Testing duplicated in-flight loads on the structure at the end of S1C stage boost. Marshall and SNID engineers are investigating the mode of failure. Original plans were for a modification of S2S for dynamic testing, but as a result of the stage loss, the all-systems test stage will be used instead. The all-systems stage, designated S2T, was completed by S&ID during September, and on October 1st was shipped to the Marshall Center's Mississippi Test Facility. After static firing there early next year, S2T will be modified and sent to Marshall for dynamic testing. At the Santa Susana Field Laboratory, preparations were underway this quarter for cluster firing of the S2 battleship stage using flight configuration J2 engines. The first firing is set for December. Also at Santa Susana, successful completion of the S2 Common Bulkhead Test Tank program was accomplished in early November. The tests investigated structural integrity and limit conditions in a cryogenic environment. Vertical buildup of the S2F facilities checkout stage was completed at Seal Beach during the report period. Systems installation and insulation closeout are now in progress. Vertical assembly is underway on S2-1, the first flight stage. During November, the aft LOX bulkhead was successfully tested to 105% of pressure for 10 minutes and is now available for stage final assembly. The forward LH2 bulkhead and common bulkhead were also completed and tested during the quarter. Automatic checkout consoles are being delivered and installed in S&ID's dual vertical checkout building. The automatic equipment is undergoing tests in preparation for vertical checkout of the first flight stage. Fabrication of structural components and assembly of major structural sub-assemblies are underway on flight stages 2 and 3. Deactivation was completed in early November at the electromechanical mock-up area at the Downey facility. Conclusion of compatibility, interference, and automatic checkout equipment verification testing terminated the EMM function, and GSE is now being reallocated to other locations within S&ID. At Douglas Aircraft Company's Sacramento test facility, the S-4B battleship stage was removed from Beta Test Stand Number 1 in September, following completion last quarter of the battleship test firing program. The stage will be delivered in early January 1966 to the Arnold Engineering Development Center at Tullahoma, Tennessee for altitude simulation firing tests. After removal of the battleship stage, Beta Stand 1 was converted in preparation for acceptance testing of the S-4B flight stages of both Saturn 1B and 5 configurations. The first flight stage, designated 501, will be installed in February 1966. The S-4B Common Bulkhead Test Specimen was delivered to SACTO in September for structural testing under cryogenic conditions. Utilizing a converted S-4 stand, testing will get underway next quarter. Also at SACTO, installation of ground support equipment at the Vertical Checkout Lab is nearing completion. Initial use of the new facility for systems checkout of the 500 ST stage simulator is slated for late December. At the Assembly Checkout Tower Complex at Douglas's Huntington Beach facility, final installations are underway on the first flight stage. The J2 engine for 501, received from Rocketdyne last quarter, underwent checkout in the components test lab prior to joining to the stage in mid-November. Work continued on the second flight stage, 502, with the installing of insulation nearing completion by the end of the report period. Tank components fabrication is progressing for the third flight stage, 503, with tank joining operations scheduled next quarter. Qualification testing of S4B flight stage components continued with such items as vibration testing of the low-pressure fuel duct, vibration testing of the liquid oxygen chill-down return duct, cryogenic testing of the aft umbilical kit, and cycle testing of the flexible hydraulic lines. The first transcontinental trip for an F1 engine by truck transport was accomplished this quarter. Previously, all transport was by air. Engine F2020 left Rocketdyne's Canoga Park, California plant on September 29th and arrived in good condition at the Marshall Center in Alabama on October 13th. The road transport feasibility study was initiated by MSFC because of the limited availability of aircraft capable of carrying the F1. This scale model depicts 2 of the 7 F1 engine vertical assembly stations to be constructed at Canoga Park. Conversion from horizontal assembly to vertical is part of Rocketdyne's general program for improvement of production line techniques. In addition to the vertical assembly stations, 3 electrical and mechanical checkout stations and 1 optical alignment station will be built. Construction work is now underway on the first 3 vertical assembly stations. The entire line is expected to be finished early in 1966. A new 2,500-ton capacity liquid oxygen storage tank has been completed at the Edwards Field Laboratory in California. The new storage tank allows Rocketdyne to meet increased testing schedules for both research and development and production F1 engines. 2 F1 engine checkout console assemblies were delivered by Rocketdyne this quarter to the Boeing Company at Michoud for installation in the first F1 checkout station there. A third unit is slated for delivery in December. The console provides electrical, pneumatic, and hydraulic inputs and outputs for the F1 engine for performing specific functional tests to determine its operational condition. At the Marshall Center's new single-position F1 static test stand activated last quarter, 3 firings totaling approximately 360 seconds were conducted during this report period. The Rocketdyne-built J2 flight rating test engine underwent teardown inspection in September following completion of FRT last quarter. The engine, number 2023, which had been static fired 25 times for a total of 2,760 seconds, was completely disassembled for detailed inspection of all components. Following preparations for the J2 qualification test series at the end of the quarter, the initial static firing of engine number 2032 was conducted on the Delta II stand at Santa Susana. The engine was fired for a full duration of 470 seconds. The qualification test series, which will man-rate the J2 engine, is scheduled for completion by December 31st. The engine will be fired 30 times for an accumulated duration of 3,750 seconds. Radio interference tests as a part of the qualification program were conducted this quarter at Rocketdyne's Los Angeles division. Overall purpose of the tests is to show that the engine will not emit undesirable interference or be susceptible to external interference. Rocketdyne's research and development program on J2 engine thermal insulation continued during the quarter. A test sample was subjected to various degrees of temperature with a plasma gun as the external heat source. The various molds are representative of engine hardware configurations. A total of 11 J2 engines was delivered by Rocketdyne this quarter to the stage users, including the final engine for S2501, all 5 engines for S2502, the remaining 4 S2 battleship stage engines, and the flight engine for S4B502. The first restartable J2 engine delivered to Marshall underwent 3 static firings, the longest for 418 seconds in MSFC's S4B battleship test stand. Restart tests are expected to begin next quarter. Throughout the quarter, Ground test instrument units were assembled and tested. Assembly of the breadboard test unit was near completion with delivery to Marshall's System Development Facility due in early December. Assembly of the Flight Systems IU was near completion by the end of November. The 3 checkout trailers used to check out the Flight Systems IU were delivered to Marshall by IBM Huntsville in September. The checkout equipment covering telemetry, radio frequency, and a digital data acquisition system is mounted in trailers so it can later be sent to Douglas Aircraft in California to monitor flight simulation tests. Structural assembly of the first flight instrument unit, SIU 501, began in late November at IBM Huntsville. Component assembly is scheduled to start in mid-January 1966. The second structural test IU, assembled by IBM Huntsville using segments manufactured by North American Aviation, was completed in early October and moved to MSFC for structural testing scheduled for December. At Wiley Labs' Huntsville facility, high-intensity reverberation test chamber, acoustic vibration testing of the vibration test IU was successfully conducted in mid-November. The tremendous noise levels produced by the Saturn V first-stage engines were simulated by a pneumatic sound source producing sound pressure levels up to just above 150 decibels over a 25 to 10,000 cycle per second frequency range. At the Marshall Center, dynamic testing of the S4BD dynamic test stage in conjunction with the dynamic test instrument unit and an Apollo spacecraft was successfully completed during the report period. At Marshall's Mississippi Test Facility, activation efforts on the first S2 static test stand, designated A2, were directed early this quarter to priority items to prepare the stand for installation of the S2T all-system stage delivered by S&ID. Beneficial occupancy of the stand was accepted on October 1st. On October 19th, the S2T was installed in the stand by S&ID and support personnel. The S2T, to be used for checkout of facility systems, ground support equipment, and the stage itself, will be the first vehicle test-fired at MTF in early 1966. Work on the second S2 stand, designated A1, progressed steadily during the quarter. Concrete work on the service core and front vents is complete, and steel erection below the flame deflector was started. At the S1C stand, MTF's other principal test element, overall progress is on schedule. Concrete work on the center and east pier is finished, and installation of steel for the flame deflector and engine removal platform is well underway. Concrete work on the west pier is complete through the 6th floor level. In summary, September, October, and November 1965 were months of continuing progress along a broad front, with achievements such as the first S1C static firing using automatic checkout equipment, completion of assembly of the first S1C flight stage, delivery of the first Michoud-produced S1C, the dynamic test stage, completion of assembly of the S2 all-systems test stage, and its delivery to Mississippi Test Facility for static firing, successful testing of the S4B dynamic test stage and dynamic test IU, successful acoustic testing of the vibration test IU, improvement of 1 engine production techniques, and initiation of J2 engine qualification testing.